Hello and welcome everyone. In the previous video, we reviewed algebraic form of simplex method, which may be best for understanding the underlying concept of the simplex algorithm. However, it is not always convenient to solve a linear programming problem in this way. A tabular form, which is the topic of this video, is instead a more convenient approach as it records only the essential information. That is the coefficient of the variables, the values on the right hand side, and the basic variables. This approach saves the computation time and it is also relatively simpler. We will solve the same example as in the previous video, this time by using tabular form of the simplex method. Again, the first step in this approach requires writing the problem into its canonical form. Please check the previous video and also the video on canonical form of LPP on my channel. The next step is to create the initial simplex tableau using the initial basic feasible solution. For that, we set up the table like this using the equations in our given problem. In the first column, we list the basic variables. In the solution column, we list the right hand side of the equations. The four columns in between will list the coefficients of basic and non-basic variables. Now, in the first step, we identify the pivot column, and we do this by looking at the objective function row and finding the column with most negative coefficient. If there are no negative coefficients, then we do not need to proceed any further, as the current basic feasible solution is the optimal solution. In this case, we can see the column corresponding to x3 variable is the pivot column. The next step is to identify the pivot row. For that, we will compute the ratio between the solution and pivot column elements. The row that corresponds to minimum ratio is identified as the pivot row, which in this case is the row corresponding to x2 variable. Now, if we compare these steps of identifying pivot row and column, we can see in pivot column we are identifying which non-basic variable enters the basis in the next iteration, and in pivot row we identify which variable leaves the basis in the next iteration. Therefore, our new basic and non-basic variables comprise of x1, x3, and x2 and x4 respectively. Next, we identify pivot element, which is the element in the cell that happens at the intersection of pivot row and pivot column. So in this case, the pivot element is 3. Now that we have identified pivot row, pivot column, and pivot element, we need to create a new table for the next iteration. And for this update, we will use Gauss-Jordan elimination method. I have a full video on Gauss-Jordan elimination method in the playlist on solving linear system of equations. Please check that and many other related algorithms if you want to learn more. In the updated table, first we replace the leaving variable in the basis by entering variable. Then we obtain the elements of the new pivot row by dividing the elements of the current pivot row by the pivot element, which was 3. So we have divided all elements in next 3 row by 3. Next, we will eliminate the pivot column in other rows. So the update rule for remaining rows is that we subtract the product of pivot column coefficients of the current row and row of the new basic variable from the current row. For example, the row corresponding to Z will be updated as follows. We have the coefficient for the current row and we have the coefficient corresponding to the new basic variable row. Then we multiply the coefficient of the new basic variable row with the pivot column coefficient of the current row. And then we subtract it to get the updated coefficient for this row. Here we can see that we got 0, 3.5, 0, 3, and 514 divided by 3, which is equal to 171.3. Since all the elements of the Z row are positive, as per the optimality criterion, no further action is required as we have found the optimal solution, which in this case is the same as we obtained in the previous video on algebraic simplex method. But this time it appeared more systematic and relatively easier to find the solution. Please don't forget to subscribe to my channel and share and like this video. Thanks for watching.